Welcome to Chapter 10, Section 5, Independent and Dependent Events. Our objective is to find the probability of independent events and to find the probability of dependent events. We have three vocabulary words to start with. The first one is compound event. Compound, just like in the English language with the compound word, a compound event is made up of one or more separate events. To find the probability of a compound event, you need to know if the events are independent or dependent. So to find the probability of a compound event, that's one or more separate events, we need to know what independent means. Well, events are independent if the occurrence of one event does not affect the probability of the other. Events are dependent if the occurrence does affect the probability of the other. Let's look at a couple examples. If we're looking at getting tails on a coin toss and then rolling a 6 on a die, is that independent or dependent? Well, since tossing a coin does not affect the rolling of a number cube or a die, the two events are independent. To look at dependent, let's look at getting two red gumballs out of a gumball machine. Well, since pulling the first gumball out is going to affect the chance of getting a second red gumball, the two events are dependent. Two events are dependent because getting one ball out is going to change the chance of getting a second ball out. What does this mean? Well, when we find the probability of independent events, we look at both probabilities of each choice. Probability of A and B is the probability of A, and then we multiply them to the probability of B. So we multiply. We're looking at two separate events. If they're independent, we're going to multiply them together. Here's an example. Let's pretend we have three separate boxes. Three boxes. Each box has a blue marble and a green marble. So box A has a blue and a green marble, box B has a blue and a green marble, and box C has a blue and a green marble. The first question to ask yourself is, what's the probability of choosing a blue marble? Well, to determine how to do this, we need to first decide if this is independent or dependent. So if I pick a blue marble out of the first box, is that going to affect what happens in the second box? No, it does not. So the choices are independent. Now let's look at what happens. Consider one of the boxes. One box has one blue and one green. So if I look at what I want over what's possible, one blue and one green marble, there's only one that's what I want a blue one. But there's two possible, a blue and a green. So the probability is 1/2. Probability of blue, blue, blue is probability of blue times the probability of blue times the probability of blue. So it's 1/2 times, that's a 2, 1/2 times 1/2. Well, as you know, as you multiply fractions, you multiply the top, the numerator, and you multiply the denominator, the bottom, and then you turn it into a decimal, and then you turn it into a percent. So the probability of drawing blue, blue, blue is 1 out of 8, which is 12.5%. Now if we have two dependent events, we have to do the following. First, we calculate the probability of the first event. Then we have to calculate the probability that the second event would occur, assuming the first event has already occurred. And then we multiply. Let's take a look at how that's done. The letters in the word dependent are placed in a box. So we have a D, an E, a P, an E, an N, a D, E, N, T are placed in a box. We're going to choose two letters at random, and we want to know what the probability is that they'll both be constants. Because the first letter is not replaced, the sample space is different for the second letter. So that means the events are dependent. So to find the probability, we need to first determine what the probability is that the first letter is a constant. So we look at wanted over possible. Well, we have 1 constant, 2, 3, 4, 5, 6 constants. So our wanted is 6 over our possible. 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So that equals 2/3. Yes, even in this, you want to reduce. Now, once the first letter is chosen, and we assume it's a constant, there would be 5 constants and a total of 8 letters. So, coming back up here, if we chose the first one, it was a constant. So say it was D. Looking at this, we would have 1, 2, 3, 4, 5 left. 5 constants are what we want. And notice there's only 8 numbers left now because we're only considering these numbers. 1, 2, 3, 4, 5, 6, 7, 8. Cross that off. That's not included. So 5/8. Now we look at what they are, what the chances are of them both happening. Well, the first constant is 2/3 times the second constant was 5/8. Those of you that remember cross canceling, you can do it here as well. 2 goes into 2 one time, 2 goes into 8 4 times. So I have 5/12. So the probability of choosing 2 letters that are both constants is 5/12. As we move on to example 3b, we will continue to look at 2 letters chosen at random. But in this case, we want to know what the probability will be if they're both constants or both vowels. So the probability of 2 constants was calculated in additional example 3a. And if you remember, that was 5/12. So now we're going to find the probability of getting 2 vowels. We're looking at the word dependent. Here's a vowel. Here's a vowel. Here's a vowel. So there are 3 vowels out of 1, 2, 3, 4, 5, 6, 7, 8, 9 events. The probability of getting a vowel is 1/3. Now, if the first letter is chosen at vowels, there will be only 2 vowels left, because if one is picked, then there's one less to pick from. And 8 letters left, because one has been drawn out. Does that make sense to you? So, for example, if I draw this and I get the 9, you now have 8 letters left, 2 of which are vowels. So, the second vowel will be 2/8, which is 1/4, is the probability that the second letter chosen is a vowel. So we take these 2 numbers, this one, and we multiply them and get 1/12. So the probability of getting 2 vowels in a row is 1 out of 12. Now the events of both letters being constants or both being vowels are mutually exclusive. Now what do I mean by mutually exclusive? Well, by mutually exclusive, I mean that they cannot both happen at the same time. So we add their probabilities. Mutually exclusive means we add their probabilities. So 5/12 from both being constants and 1/12 from both being vowels is 6/12 or 1/2. So the probability of both letters being constants or both being vowels is 1/2. Simply remember that 2 mutually exclusive events cannot both happen at the same time. See you in class tomorrow.